Hello there, my name is Jürgen Gerhard from Maplesoft, and I'm welcoming you to this recorded presentation about Maple 2021 gems that you may have missed. I'd like to start by improvements to mathematical algorithms and mathematical features of Maple 2021, which I think many of you will be interested in. One of my favorites here is a new option to the integration command. It's the method option for indefinite integration. So this option was already available for definite integration, but now it's new for indefinite integration. We see here an example where two different methods give vastly different results. Also, if you give it the special value to this option, return verbose, then you will see the results from all the indefinite integration methods. For comparison here, we see the same thing for a definite integration, which was possible before already, but there's more definite integration algorithms than indefinite ones. There's also some improvements for multivariate limits. So here is a polynomial that's not homogeneous, but it's weighted homogeneous if you give weights to the variables. And the next command proves that this polynomial has only an isolated root at the origin. So this is something that the multivariate limit package is very good at. If we put that polynomial in the denominator, a polynomial in the denominator that has an isolated root, then there have been many improvements for previous versions of Maple to be able to compute those limits if that polynomial is homogeneous. But these particular limits, earlier versions of Maple would not have been able to compute because the polynomial is weighted homogeneous, but not homogeneous itself. So now that is supported as well. The next exciting feature I want to talk about is automated discovery of plotting domains, of nice plotting domains and ranges for visualization. So here's a 2D plot, which in previous versions of Maple would show the default ranges from -10 to 10 on both axes. So in particular, it would be centered, so you would not see that this is actually a parabola really well. And here's another example where the function grows fairly quickly, and now Maple increases the y range considerably in order to show you that. We have something similar for 3D plots. So in previous versions of Maple, this would show you an empty plot because most of the values of the function being plotted are complex. So it tries to find an area of the XY plane where the function has real values and shows you that. For the special case of 2D plots, when you're considering a rational function, as in this example with a numerator of degree 3 and a denominator of degree 4, then what the new feature will do, it will automatically determine those points of special interest. So those are inflection points, maxima, minima, roots, and so on. And it will make sure that the plot shows those and goes through those points. I'm moving on to a new feature, or a feature that many of you are excited about, LaTeX export. This has been vastly improved. So we see here a worksheet with a longish formula. It has a plot in it, it has an image in it, and it also has a working hyperlink in it. And so this is how you would do export to LaTeX. That hasn't changed. Export as LaTeX. Ask you for a name. I'll change the name to LaTeX 1, so it's different from the worksheet. And then once the wheel stops spinning, the files have been generated. We can look at them. So what you can see here is LaTeX 1, the actual LaTeX file. There's an image that was exported as a pixel graphic. There's an image that was exported as a vector graphics. Now I can run the LaTeX command on it. I'll do that twice. And then I can open the generated PDF file. And you can see a number of things. So first of all, the formula, which is very long, was line broken nicely. So this is a new feature using a special LaTeX package, which supports that, which the LaTeX export now has. Second thing you can notice is the plot is much bigger by default. So in previous versions of Maple, well, it's not necessarily the size. In previous versions of Maple, this plot may have been on a separate page, but now it's a more reasonable size. And it goes with the text. Images are supported. And hyperlinks are supported as well, and in particular, they're clickable. If I click on that hyperlink, I get the corresponding page. Okay, going back to my presentation worksheet, I want to show you some user interface improvement. Actually, my gem here is improvements to code edit regions. If you have a mixture of Maple commands and code edit regions, then previously what would happen if you hit enter on a Maple command, it gets executed, and now the cursor goes inside the code edit region. But previously what would happen if you keep pressing enter, it would just add new lines. It wouldn't execute it. But now if you press enter on the code edit region, which you don't see, but the cursor is actually in there, it will execute the code. And there's a few other interface improvements, which unfortunately I don't have time to get into. We have some improvements for ODEs. Maple has always been at the forefront of being able to compute symbolic solutions for differential equations. So here's a second order differential equation with rational coefficients. And Maple can now compute a symbolic solution in terms of hypergeometric functions. And here we just verify that it actually is a solution to the equation. Here's another example where the solution can be expressed in terms of specific hypergeometric functions, namely Bessel functions, or another example where the answer can be expressed in terms of Kummer functions. Finally, here's an example that Maple was able to compute before, but it's a fairly lengthy answer. It's still correct. But now if you give the special option hypergeometric solves, then you will get an answer in terms of hypergeometric function, which the previous answer was not, and it will be more compact. There are quite a few improvements to the graph theory package. There's 8 new commands. I don't have time to talk about all of them. One I want to highlight here is the identify graph command. So this is able to recognize if a given graph, which you can import from somewhere else or you construct it yourself, is isomorphic to one of the known graphs from the special graphs package. So here we start out with a special graph, namely the Hoffman-Singleton graph, but we modify it. So we take the edge 100, which is defined by the vertices 20 and 25. And then when we look at the neighborhoods of those two edges, and we remove those two neighborhoods, including the vertices from that edge itself. So that will remove, in total, the neighborhoods have 14 vertices together. And it will remove almost half the edges because all the edges adjacent to those vertices will be removed as well. So we have a new graph, which Maple does not know about, and it tries to identify whether that graph is isomorphic to one of the known graphs. And indeed it is. In this case, it's isomorphic to the Sylvester graph. Here are some other additions, which are nice to show. About 16 new special graphs were added to the special graphs package, among them the banana tree, the butterfly graph, which is well known to people doing Fourier transforms, fast Fourier transforms, the crown graph, a few graphs related to chess, the king's graph and the knight's graph, and a few and the queen's graph as well, and a few probably more esoteric special graphs. Next thing I want to show are solution steps. So Maple already had previously commands for showing solution steps, but some new commands have been added to the Student Basics package, for example. So here's a new command for long division. I should execute this first. So this is long division of polynomials, but it can also do long division of integers. The solve steps command can support quite a variety of equations, not just linear equations. Here's a non-linear equation with an exponential, and it gives you an answer, the answer in symbolic form in terms of a logarithm and also as an approximate answer. In the student package, we have the linear algebra tutors. One of them is the inverse tutor, and the inverse tutor previously was able to give you a step-by-step solution, but it would show up in a separate window. And now this can be given in the worksheet itself. I'm skipping signal processing and moving on to approximate polynomial algebra. What does this mean? So there's a new package called Polynomial Tools Approximate. which has a number of view commands. I only want to show you one example, namely the example of factoring. I'm starting out with an exact polynomial which has two designated factors. It's a polynomial of degree 5 and two variables, as a factor of degree 2 and a factor of degree 3. And what I'm doing now is I'm adding a small perturbation to it on the order of 10 to the minus 8. And I'm using the factor command from the approximate subpackage. And that will give me an approximate factorization. There's a leading coefficient and there's two factors. So it got the number of factors right, at least. And what we see, there's a number of coefficients in there which seem to be spurious. They're very small. And I can get rid of those by using the fnormal command. And actually what I'm doing now is not this, but I'm expanding the polynomial, which will also give me lots of spurious coefficients, which I then remove using fnormal. And then I compare this to the original polynomial. So here's the expanded form with all the small spurious coefficients removed. And you can see it has exactly the same coefficients as the input polynomial, and they're pretty close. They're all visibly 1 or minus 1, and the error is very small. And to confirm that, we compute the relative error, which is on the order of 10 to the minus 9, which is the same order as the perturbation that we introduced. So that's reassuring. Now, one thing that's nice about this package is that for many other approximate polynomial factorization commands, you will have to guess what the degrees of your factors are first. And then once you have an idea of what those are, then the package can give you an approximate factorization into factors of those degrees. But this package automatically figures out what the degree should be by looking at the rank or the rank deficiency rather of the Rupert matrix, something which I didn't show here. The last gem I want to show about Maple 2021 is a new feature in the list tools package called list tools Steel. So when I'm dealing here, I'm dealing a deck of cards made out of the 4 suits: diamonds, spades, hearts, and clubs. And I use the existing shuffle command. This is not new, to shuffle the deck. And then I use the new deal command. I'm giving it the argument 4, and that means deal the deck to 4 players. I could deal it to 3 or 5 as well, of course. And that shows me the hands that all the 4 players will get as a result. Yeah, I just used the nice animation, the nice visualization showing you the symbols, the well-known symbols for the suits. There are other language improvements here, which I don't have time to go into. I want to conclude my presentation by showing you, giving you a sneak preview of one of the new features that we will have in the next version of Maple 2022. This is the conversion to formal power series. So the command, the interface for the command is convert, and then a function, and then you convert it to formal power series. And here are a few examples where the new command does much better than the one that was in Maple 2021. So here's a function that the new command can convert, in this case, to a sum of 2 series. Not all of them are power series, so it's a bit of a misnomer because it actually can handle formal pre-series series as well, which we have here in the first command. And it has better support for those than the previous version. So here's an example where in Maple 2021 we couldn't compute it, and now we can, and it's the result is a series which has a coefficient that's not even, well, actually it's polynomial, just puts the logarithm in. The new command has better support for sums of hypergeometric functions. So here's an example where we take the sum of 2 terms, and each of them is hypergeometric, but the old command would not automatically map, but the new command does that here. So you don't have to map it. Here's an example where even if you map it, the old command would not be able to convert the second part in the sum. That's because of the fractional exponent. So that's now being handled much better. So you get a sum right away, and you get a power series this term times in terms of z to the 3 for the second term. Here's another example where I think the previous answer was wrong because there's a term of 1 missing. Maybe not. Anyway, so if you map it, you get the same answer as before, but now the new package combines the two sums into one. That's the only difference. In many cases, you get more compact answers. So here's an answer which was very long in Maple 2021. In Maple 2022, it's much shorter, and that's because in this case, the new command does not combine the sums. However, you are given control over whether those sums should be combined or not. So this is an example which the old package couldn't handle at all. In the new package, by default, it gives you an answer in terms of 2 sums, but you can say you want the output to be expanded, and then you will get an answer in terms of 1, 2, 3, 4, 5, 6 sums, which have simpler summands, but overall it's a little bit longer. Okay, and the last thing I want to show here is an advertisement for Maple Transactions. So Maple Transactions is a new journal, fairly new journal. The first issue has appeared, has just been completed. Its purpose is the dissemination of excellent expositions on topics of interest to the Maple community. So that means the focus is on exposition, not so much on novelty. So if you're doing something, if you have a new application for something that is known, or if you have a new visualization of something that is already known, but that would be of interest to Maple users, then that is a very welcome contribution. We accept a number of formats, so it could be a traditional PDF, or it could be a video, or it could be a live Maple worksheet. And while we strongly encourage the use of Maple, it's not actually a prerequisite. The journal is completely open and free, so neither the readers nor the authors have to pay anything in order to contribute or read the articles in this journal. We have a fairly large editorial board of well-known names in the Maple community and in computer algebra research and education. Overall, almost 60 people. And quite a few people from Maplesoft are on the editorial board, among them myself and Paulina, who is one of the co-organizers of this conference, together with Rob Corliss. Together they are the program chairs of this conference, and Rob Corliss is also the editor-in-chief of this new journal, and so far he has done an excellent job on shepherding everyone and overseeing contributions. So that is everything I wanted to say here. Thank you very much for your attention, and I hope you enjoy the rest of the conference.